Good evening, guys.
Good evening, sir.
Today we will discuss about starter. Okay. So how many type of starter we have on board the ships? How many type of starter we have on board the ship? Looks like
Three
Saurav
things.
is still connecting. Looks like. Let him connect. Saurav, you are there? Okay. We'll just wait for him to connect because he's showing he's still connecting. Looks like he's facing some difficulty in connection. He sent a message in Telegram group also. Should I wait for him or we'll continue?
We will wait, sir. No,
Okay. Okay, you were not there in yesterday class, right? So I will start discussing what we discussed yesterday, so that by the time we will be able to log in, we'll continue with the starter. Okay, so that your time will also not get wasted. Fine, Vignesh.
Yes, sir.
Okay. So yesterday, I hope you can see my screen. My screen is visible to you.
Yes, sir.
Yesterday we were discussing these questions, written questions and answers. So the first question was differentiate between squirrel cage rotor and wound rotor motor of three-phase AC induction in respect to the following: A, rotor construction and torque characteristic; A is rotor construction, B is torque characteristic, and C is speed variation. So when we talk about rotor construction, the squirrel cage rotor consists of a set of conductive bars. Can you see these bars? There are set of conductive bars and they are made of copper or aluminum. So material of these bar are copper or aluminum that are short circuited by the end ring. So their circuit is getting complete by the end rings. The bar at the end ring resemble the squirrel cage design, hence it named as a squirrel cage rotor. The advantage of the squirrel cage rotor are simple in construction, robust, robust, and require minimal maintenance due to the absence of the slip ring. So as you can see, if you have overhauled any motor on board the ship, we can only see a cylindrical shape, right? And it is having a shaft at the center, right? Correct. This is the design we are seeing on board the ship.
Yes, sir.
So there is no slip ring and
Yes, sir.
anything in this motor. So this is the advantage. And they are cost effective and widely used in most general purpose application. Disadvantage, the squirrel cage motor have a limited speed control capability. So nothing is connected outside of the rotor. So this becoming the disadvantage because you cannot control the speed of the motor. Obviously you can control the speed of the motor, but you have to put something like VFD, and VFD is costly thing, right? So that is why we are using the squirrel cage motor. That is the limitation of the squirrel cage motor. He's asking for passcode 486418. That is the disadvantage of the squirrel cage motor. The next one is wound motor and rotor construction. So when we talk about wound motor rotor construction, can you see this diagram? Now we have the slip ring and the brushes. And can you see the three-phase wires are connected to the
ओके
slip
सर मैं आ
rings?
गया
Yeah. So
हाँ सर पढ़ा पढ़ा हाँ, मैं
I
भी
thought you were facing the difficulty in connecting, so I started the question which I discussed yesterday with you.
नो
I'll just
प्रॉब्लम
complete one question, then we'll move to the starters. Okay. So you can see these wires are connected to the slip ring, and now they are going outside. Now you can control the, or you can explain, Saurabh, then it will be beneficial for you.
sir these are resistance which are attached to slip ring. This is our external circuits. So whenever we have to control the torque, and control the speed. We can increase or decrease resistance as per our need, and this is only provided in wound rotor, but in squirrel cage, as we know that every winding and everything is inside cage. That's why we are not able to control anything from external circuit, because we cannot attach external circuit to armatures. And so we this is advantage of wound rotor, that we can control is a variable speed control, adjustable torque, and but it is not disadvantage is that it is very complex in construction, and difficult for maintenance, while squirrel cage rotor is easy in construction. But problem is with that is that we cannot control speed, and it has a high starting torque in start, and that's why it is cannot be used for very big uh, this motors.
Obviously, we can control the speed, but we have to put the VFD, and VFD is a costly thing, especially for the bigger motors. Okay. So next is torque characteristic. Squirrel cage motor have a simple, robust design with bar and conduit loop on the rotor that resemble a design of the squirrel cage. They provide a high starting torque, but have a lower torque control capability during the operation. So in starting, the torque will be high, but during the operation, the torque will be low. This type of motor is suitable for the application where constant speed and is required, and where control of speed is not required. Next is wound motor rotor. Wound motor rotor have a more complex construction with a rotor winding that allow external resistance to be connected. So you can see in this motor design, now these wires are going outside. You can connect any resistance to this wire and change the speed of the motor and torque characteristic curve. With a rotor that allow the external resistance to be connected, this enable the better control over the torque and making them suitable for that require adjustable speed and torque control. By varying the resistance in the rotor and motor torque and the speed characteristic can be tailored to specific requirement. The next one is speed variation. Squirrel cage motor typically operate at nearly constant speed, known as synchronous speed. How to calculate synchronous speed? You already did some numericals.
120 F upon P.
120 F by P, which is determined by the frequency of the AC supply and number of pole in the motor. They have limited speed variation capability and are not easily adjustable for speed control. Wound rotor motor offer more flexibility in speed control. Obviously, again, by adjusting the external resistance connected to the rotor winding, the motor speed torque can be modified, and this allow for a wider range of the speed variation, making wound motor rotor suitable for the application that require variable speed in operation. Okay. So now we will go on the starter. So how many types of starter we have on board the ship?
A soft starter, star
Hmm.
delta, and
DOL, right? So why we need starter? When the winding of the induction motor are switched directly to onto a three-phase supply, a surge of current is taken in the motor, which dies away when the motor expands up to design speed. This starting surge current can be of the 8 times of the motor rated current, and it occurs because there is a no generated back EMF, no generated EMF in the winding to control the current at standstill. So because there is no EMF in the winding, so it generates the high current when they are starting, and that is of the 8 times sometime. Starting a motor by simply connecting it to a supply is called direct online starter, that is DOL. And this is the simplest and most economical method of starting. Most marine diesel engines are direct online started. Special reduced voltage starter such as start delta or auto transformer type are used when excessively large starting current. Obviously, when motors are small, like your Bills pump, your sludge pump, we don't have the start delta, right? We have the direct online, or we
Yes,
have
sir.
the start delta.
So we have star delta in some starters and direct online for small,
Small
small.
pumps, right? May cause the severe voltage dip on the supply, which could affect the operation of the other load. Large motor and the smaller motor intended for the connection to the emergency center use the reduced voltage starter. If something is coming from the emergency, we will try to use this starter, especially star delta. It is important that the motor accelerate quickly to the predetermined speed to prevent the excessive long run times causing the over temperature in the stator winding insulation. Obviously, over temperature, then your winding will insulation will go away and your motor will burn, right?
Yes, sir.
Long duration voltage dip on the supply. Run up time depend on the starting torque developed by the motor, which in turn is proportional to the square of the voltage. So starting torque is equal to the square up of the voltage. Obviously, the load on the motor will be also have an effect on the run up time. It is worth noting here that the magnitude of the starting current is not increased when the motor is starting against the load. The value of the supply voltage and the standstill impedance of the starter winding only determine the starting current. This figure is going to come into the next slide, figure 3.3. Show that the unloaded motor which reach their idling speed very quickly and even when started against the load, most run-up time should not cause the problem. Some drives, such as centrifugal large fan, may require special high torque motor, which motor, if acceptable run time, are to be achieved. Modern standard motor are designed for high efficiency and minimal manufacturing costs. They usually have a large starting current and poor thermal capacity. When the run-up time are exceed to 10 seconds, a large standard motor or special high torque motor is used if the run-up time is more than 10 seconds. So now we will discuss about direct online starter. So this is how your direct online starter looks like. These are the lines coming from
Must be.
MSB or ESB, right? There will be main breaker known as KM1. These are the contacts. These are the contacts and these are the fuse. So this is the control circuit. This part is the control circuit. So control circuit, this main circuit is of how much voltage?
440.
For 40. Then you are going to take the tapping and put a transformer and reduce it to the 24 volt or whatever voltage you require for your control circuit.
Okay.
Now you are making it like this,
So
and this is the
टैपिंग डायरेक्टली सर वो KM1 के पहले से लेंगे या उसके बाद में लेंगे द टैपिंग विच वी आर टेकिंग फॉर ट्रांसफार्मर हेलो सर
yeah, I'm just drawing. This is the main bus bar. This is how your main breaker will be connected, right? So you will take tapping Okay,
Okay. Got it.
like this. Now your control circuit will be present here. Understood?
Okay, sir.
So in this is direct online. So what happens? As soon as you are going to press the start switch, as soon as you are going to press the start switch, this KM1 will energize, KM1 will energize, this breaker will close, right? Because they are connected. Can you see here?
Ah,
And this will close and motor will start, right? If you want to stop the motor, you have to end this. If you are leaving this retaining contact will come into the picture because KM1 is already energized. So this will close. So this is normally open. As soon as you are going to press it, it is going to make the circuit, but you are going to leave it, it will again leave the circuit. But by that time, this contact will already made and your motor will keep on running. Okay, the supply will come from here for the KM1 and KM1 will close these contact breakers. So now if you want to stop the motor, this is the stop switch. You are going to push this one and it will come to this position. So now no more power supply to the control circuit. KM1 will de-energize. KM1 will de-energize. So these will go back with the springs, right?
okay.
Understood the working of the DOL?
Mm.
This is very easy, nothing to explain actually. This is the circuit when you have only the local control. Circuit will get complex when you want to start your motor from a remote location. Local control in this circuit, what we discussed right now, it was having a local control. For starting is achieved by the help of the manual push button. So what was the manual push button? This one I, right? This one the manual push button. Stopping is achieved either by with the help of the manual push button or automatically when the thermal overcurrent relay operates. Obviously, if this relay is getting operated, overcurrent relay is getting operated, your motor will stop, right?
Yes, sir.
Or the voltage surge occur. This setting is manually done after operation of the thermal overcurrent relay. If it is stopping on this overcurrent relay, you have to reset it manually. Protection is by a three-phase thermal overcurrent protection. So in this motor, we have the protection with the thermal overload relay, and it protects you against overload, phase unbalance, and phase failure. Opening of the enclosure door is only possible. So when you can open the enclosure door of any motor,
When the breakers are
so you have to
isolated.
switch off this breaker, right? You have to switch off this breaker, main breaker, right? Normally main breaker are always on, correct?
Hmm. Hmm.
So you have to switch off this breaker, then only you can. So what you are seeing in these diagrams, what you can see in this diagram, it is not like that in physical thing you will find the same pictures, okay?
Yes.
So what we have for this one? For this one, we have only this switch, right? On off,
On
right? When you push down, it is off. When you put on or push it upside, it is on, right?
hmm.
And so when we discuss the circuit diagram, things look different, but actually the things are different. Like
केएम कॉन्ट्रैक्टर में वो चैट हो रहता है.
this is your hydraulic, right?
Mhm.
So what is this as per hydraulic circuit?
Or 2 by 4 spool valve.
2/4 fuel valve, and liquid is only flowing in one direction.
Hmm.
So it is acting like a non-return valve, right? Or if I'm putting this one,
Energizing it.
if I'm putting this is now hand operated non-return valve.
Yes, sir.
So what is hand operated non-return valve? Oh, really sorry. This is a hand operated non-return valve, right? So don't confuse yourself by seeing at the diagrams.
Hmm.
In diagram, things look different, but actually they are different. So this is the working operation. When you press the push button, contactor coil KM1 is energized. So KM1 will energize as soon as you are going to press the I. KM1 power contact close and motor start. So as soon as it is going to energize, this power contact will also close and motor is going to start. Auxiliary contact of KM1 close so that the start push button add can be released. So this is the auxiliary contact of KM1, right? Retaining contact. So this will also close so that when you are going to leave the push button, your motor will not stop. So this is we call retaining contact. This one we called as
Retaining.
retaining contact. If the supply voltage fail, KM1 de-energize and open the contact. And is obviously if there will be no supply, this coil will de-energize and contacts will open. When the power supply is restored, the motor can only be restart when you are going to press the start button. So it will not restart until unless you are going to press the start button. To stop, push button. Either you can stop by the push button, or obviously if there will be overload phase imbalance, this overcurrent relay will be get operated and it is going to stop the motor. This is the same circuit, but this is for the remote. Suppose you want to, what is given in the dotted line, these are from a remote location. Okay. So now you want to start the motor, you are going to press this one. Same function again. It will circuit will get completed from here and KM1 will close. KM1 will energize and it will close the main contact of the KM1, and KM1 retaining contact will also be closed and motor will start.
ये बीच में सर कौन सा आई है?
This is for the local start. So you must have seen there are some motor in engine room which we can start from the multiple location, right? Like our supply pump, circulating pump, we can start from ECR and we can also start from local. So understood? But if you are going to stop and lock from any position, then you cannot start. Can you see? All the stop switch are in series, where your start switches are in parallel. So even maybe this something wrong with this start, still you will be able to start the motor from the remote. But something wrong at the stop, you will not be able to start the motor because stopping is still acceptable, but starting a machinery without knowing the actual condition is dangerous, right? That is why instead of putting the stop switch into the parallel, they are put into the, they can also put stop switch here, right, for the remote operation if they
Yeah.
want to put, but they are not putting like that. They are putting in the series. Understood the difference? Rest all working is same. Okay. Remote control, the addition of a control station, parallel start and series stop button facility of the duplication. So you must have seen before every sludge discharge or before every bunker, we are testing the remote stops, right?
Yes, sir.
And if you have operated the remote stop, you have to reset it from same position until unless you are going to reset, you are not you will not be able to start. Okay. So next one is start delta. I hope no doubt in the DOL. DOL sometime comes in the exam, written exam to draw. I think yesterday one question was there.
Yes, sir.
कुछ था ना starter का कुछ तो question.
Yes.
Okay, anyway, we'll continue with the start delta because I need at least 20 minutes to finish start delta. So this is your start delta circuit. What happens? Your motor starts in the star condition so that yesterday we discussed star and delta. What happened in the star?
The star, the voltage is reduced by root 3, divided by main line voltage is divided by root 3, and current remains the same. So that
So this in this figure, this is a delta connection and this is a star connection. In star, your voltage, line voltage is 1 by root 3 of phase voltage. Whereas in delta, your current is, line current is 1 by 3 times of phase current.
is
Okay, just keep this in mind and now we will be going to discuss star delta, starter. This motor is used to reduce the starting current in the 6-terminal motor design for delta operation. Why 6-terminal?
6 terminal because for 3 terminals for stars and 3 terminal for delta.
3-terminal for star and 3-terminal for delta. It is the most cost-effective method of reduce the voltage starting. The motor is direct online started. The star winding are star connected. So when you are connecting your motor, initially your windings are in star phase. The starting current and torque are about 30% of the value obtained by the DOL starting. So the starting current will be 30% obviously because you are reducing the voltage also. Starting high inertia load may be a problem in which in which case a motor a high starting torque must be used as an extra cost. When the start push button press KM. So when you are pressing the start push button KM, KM2 close together. So when you are pushing the start button, KM1, KM1, and which one is star here? Which one is delta?
The star is one with 1, 2, 3, 5. Yes, sir. Right, all right, all right.
This one is star, right? This one is star. I hope you can see this figure or it's becoming difficult. What is KM1, KM2?
That's a chota hai. And now it's okay.
So this one is star, right? Yes, right?
No, sir.
Guys, yes or no? At least say yes or no.
Yes, yes, yes.
Yes, sir. Yes,
Okay.
sir.
Okay. So when you press the start button, KM1, this is KM1, and KM2, this is KM2, they close together. That we will discuss in the control circuit how it is happening. Okay. That's for the timing, just understand how it is working in the power circuit. This is the power circuit. Okay. I hope you understand what is control circuit and what is power circuit.
Yes, sir.
Okay, very good. And this is your motor here, right? Which connect the motor U1, U2, U1, U2, V1, V2, W1, W2 in a star connection supply, star configuration supply. A time delay of approximately 8 to 10 seconds. Sometimes in oral, they ask the time delay. Is set to allow the motor to run up to 80% of its speed. So in 8 to 10 seconds, motor will come up to the 80% of the speed, at which point your KM1 op yes, KM1 opens and close the KM3. Your KM1 is going to get open and KM3 is going to get closed. So that motor winding configuration is converted from star connection to delta. This contact will close and this contact will open. Now your motor will run in delta, not in the star. Power circuit is clear?
Yes, sir.
Okay. Power circuit is easy, right? The only difficult part is control circuit. So this is the curve. On the y-axis, we have the current. On the x-axis, we have the speed. So current with the star connection. When you are starting your motor in the star, this is the current path it is following. Maximum it is going to 2. Then slowly it is coming down. Then it is, what is happening here?
सर ये करंट बढ़ रहा है सर, डेल्टा में चेंज हो रहा है.
You're changing over to delta and this is the maximum current. But if you are starting directly on the delta, its current will be very high and then slowly it will come down, right?
Yes.
You can draw this graph in the examination, okay, if required. The switchover between star and delta is automatic. We are not doing anything. It's only by the timers. Using a time delay relay or delayed auxiliary contact on the contactor. In addition, a time delay must be inserted between switching off the star connector and switching on the delta connector to ensure that switching arcing in the star connector has been quenched before the delta connector is closed. If switching over is too fast, a short circuit will occur. So we need some time delay. It should not be like your star is open and your delta is closed, because then any breaker when they open, we have the arcing, right? In our ACB also we have the arcing, right? That is why we are using the different kind of ACB, different kind of circuit breaker, like air circuit breaker, vacuum circuit breaker, right? So there should be time delay so that this can be quenched. Otherwise, when delta is going to make, again some marking will be there, and is the chance that there can be short circuit because temperature will be high, and at high temperature, all of us know insulation of the material goes down. Conversely, if the switching over time delay is too long, and suppose you are waiting too long, obviously the motor speed will fall, right? Your motor speed will fall. So the delta closing current become excessively high. Again, your delta closing current will high because your motor is running slow. How this make the start delta arrangement ineffective? So this is going to make the start delta arrangement ineffective if the time is too long. Once time delay has been set in the starter, it is important that they are not altered, and if the open transition surge problem are to be avoided. So if you are a chief engineer, never touch the timer of the start delta transition period, okay? And even if your electrical officer is saying to change, don't change it. Understood? They are factory set for a design motor. So normally we say when U1 end of one connector is connected to the starting of the other connector is a delta circuit, right?
Yes, sir.
So here I'll make it big. I think it will be difficult for you to see. So here U1 is connected to V2. V2 is connected to V1. V1 is connected to W2. W2 is connected to W1. And is in this one U1 is connected to W2. W2 is connected to W1. V1 is connected to V2. V2 is connected to V1. U1 is connected to U2. So which one is correct and which one is wrong and why?
Sir, sir, first is sir, left side topmost number one, A1 is star.
Yeah,
Okay,
A1 is star.
U1 should be connected to U2 and U2 should be connected to uh, V2.
Mm. U2
But
should be connected to
sir, U2 should be connected to uh,
V1 if you are going
W. हाँ
V1.
सर हाँ
Mm.
U1 तो सर उस तरह से डेल्टा होता है मतलब कि U2 should be connected to V1
So we can connect like this also, no? U2 can be connected to U1
हाँ
and
U2
U1 connected to V2 and V. So this is the correct configuration, right? In this one, your circuit is running in the wrong wrong wiring because UN is connected to W directly. UN cannot be connected to W. Okay. So a further problem can occur due to the switchover if the motor delta connection is not as shown in the figure 13.1. So if you are another problem can occur if your motor circuit is not connected as per this connection in the delta. When the switching from the star to delta, the starter current stops flowing when the star contactor open, but the rotor current flow in the closed circuit and they decay gradually. So obviously in the stator there will not be any current when the star connection is open, but rotor is still rotating, right? So it is having a current in the closed circuit and this takes time to decay. It cannot be instantaneous decay from their instantaneous value at the moment of the switching off. The device decaying rotor current are direct in nature. So this current which is getting generated in the rotor, it is a DC current and produce a flux which is stationary with respect to the rotor conductor. So it is going to produce the flux in the stator. This flux rotate with the rotor and cuts the stator winding and induce the EMF just like an alternator. Correct? The frequency of the EMF in the stator falls at the rotor deaccelerate because there is no power. And if the supply is going to reconnect with their EMF is out of phase. So if you are going to close the delta contactor and if you are connecting your delta is connecting in this way, this is also correct delta. But if you are connecting in this way, so their EMF will be out of phase with the supply voltage.
सर
And
ये
there
जो U2 है U2 और W1 है वो किधर कनेक्टेड है
U2
ऊपर ऊपर वाले में जो
ये तो
डेल्टा वाला ऊपर
मेन
वाला
सप्लाई आ रही है ना इधर तो.
है ओके
So they have the surge current can be lead to the momentary torque up to 10 to 15 time of motor full load torque. So we have to connect our circuit in this manner. If we are making delta in this manner, is EMF will be out of phase with the EMF created by the rotor when there is no connection. Okay. Next is overload relay setting. There will be overload relay, obviously. Okay, we'll discuss this one later. First, we will discuss the control circuit. So this is the power circuit, right? And in the power circuit, first we only discussed how much? We only discussed this
Sir,
much,
starting is starting.
right? So now they have added one more thing. That thing is a protection, right? Thermal cutout. They have added in the line so that if motor is drawing more, getting heated, your motor will should stop, right? This we are going to discuss later how it works. So this is how your control circuit looks like. Again, what is F1? You're putting some fuse.
Yes, sir. Fuse, sir, Q1 is, sir,
So this
starting,
is Q1. Q1 is what?
starting.
Start.
नहीं, sir. And this is stop, again stop.
Normally close, right?
ये सर energize होगा, starting S2, S2 है, S2 K1, हाँ KM जब close होगा तो S2, press S2 तो close के लिए.
KM1 एनर्जाइज हो जाएगा. KM1 एनर्जाइज होएगा तो ये सर्किट यहाँ से बन जाएगा even if, right? And as soon as this will complete the circuit, KM2 will also energize. And you are, even if you are going to uh,
सर वो छोड़ देंगे बटन तब भी
start switch, it will continue to supply from here.
retaining होगा.
Okay. Then finally,
Sir, finally there will be.
this is the interlock, so that your star and delta cannot make the circuit together, right? Right now they are in this condition. If delta will be in use, this will make like this and this will come out of the contact, right? Okay. So now we will see what is actually written. Just remember the circuit. I think I should make it little bit bigger. You still, it's visible on your screen or it's going out of your screen?
visible.
Visible.
Okay. So this is F1, Q1, F2, S1, S2, KM2 is here. This is a which contact?
So retaining contact.
Retaining contact. KM1, this is solenoids, coil, not solenoid, coil. KM2, KM3, when they energize, do you remember the power circuit? It's same connected like a delta, right? So these are going to close the main breakers, right? They are going to close. Can you see KM1? When it is getting energized, this is closing this breaker. Okay, understood? Okay. So Q1 is closed manually. We have to close the Q1. Normally, when you see some books, they will not show you the Q1. Okay. It's up to you. You want to show or you don't want to show. Okay. Closing KM1 result in the star connection. So obviously, we already discussed this thing in the power circuit. And closing KM2 complete the water supply for water supply, right? The
वो तो
opening of
retaining अपने आप होगा ना सर.
मोटर सप्लाई तो अपने आप जैसे ही KM1 पहले बंद हो गया, KM2 भी एनर्जाइज हो जाएगा ना. पहले KM1 का रिटेनिंग कॉन्टेक्ट बनेगा, उसके बाद ही तो KM2 एनर्जाइज हो पाएगा. पहले स्टार ने अपना जो उसके 6 टर्मिनल निकले हैं, आपने उसका स्टार बना दिया अपनी मोटर को. नाउ यू क्लोज द मेन ब्रेकर, राइट? ओके, आई विल जस्ट गो बैक.
मैं समझ गया सर.
समझ गया? बोथ ऑफ यू?
Yes, sir.
Okay. So Q1, it's up to you whether you want to draw it or not. Okay. I will not force you to draw Q1. I don't know. Maybe surveyor will also get confused that why he drawn the Q1. Okay. Better don't draw. Because in all of the places in all of the book there is no Q1.
Hmm.
Closing, the opening of KM1 opens the star connection, and closing of KM3 result in the delta connection, and motor now run at the nominal speed and draw the nominal current. Press S2. You are pressing the S2. KM1 close. Your KM1 is going to get close. Why? Because KM1 is getting energized. And this is going to energize the
KM2.
KM2, because KM2 circuit is also getting completed. KM1 and KM2 are retained by KM2. Okay, these circuits are retained by KM2. Even if your KM1 is open, the circuit is getting complete like this, right?
Hmm.
If it is open now, KM2 de-energize the KM1. KM2 de-energize the KM1. How? This is
KM.
normally close. When KM2 is energizing, this will come out, right? KM1 and KM,
KM2 and KM3 are.
yeah, KM3, it should be KM3.
KM2 and KM3.
KM2 and
KM2 से आया सर, नीचे कॉन्टेक्टर में गया, कॉन्टेक्टर से इधर से आया, ये इसको ओपन कर दिया
हाँ,
और KM2 को ओपन कर दिया। KM2 को जब ओपन करेगा तो KM3 वाला बंद हो जाएगा।
KM3 will energize. The motor stop by operating, you can operate S1, right? Then your motor will stop. Remember, you have to close the Q manually. So don't draw the Q in your circuit. Electrical interlock between KM1 and KM3. There is a electrical interlock between KM1 and KM3 so that both of them are not closing together. Time delay contact between contact block has a time delay of 40 microsecond between opening and closing.
तो टाइम डिले वाला जो है ना, ये भी तो हम लोग लगाते हैं उसमें सर्किट
आगे
में।
आएगा, नेक्स्ट सर्किट में आएगा वो धीरे धीरे। आई एम एडिंग द कंपोनेंट, आई एम नॉट एडिंग एवरीथिंग इन वन गो।
Okay.
This eliminate the risk of short circuit on changing over from the star to delta. Many star delta starter are fitted with the mechanical interlock between the contactor KM1 and KM3, which prevent the both of them being closed at the same time. If they are closed simultaneously, there will be short circuit. Okay, time is already 9 o'clock. So tomorrow we are going to complete the remaining of the star delta, time delay and all. And then we are going to discuss about auto transformer. Okay, the working of the auto transformer. I hope you are understanding star delta better than earlier what you know.
Yes sir.
Okay.
Yes, sir.
Okay, guys. Thank you for your time. I hope classes are useful.
Yeah.
Okay.
Yes, sir.
Then see you in the next class. Next class
Thank you, sir.
tomorrow or on Sunday.
Yeah.
Okay. Tomorrow also and Sunday also. In Sunday, I have to compensate for the day I have not came on time, right? I don't remember which day.
ठीक है सर।
Thank you, sir.
Okay, so I'll take
Thank you.
class on Saturday also and Sunday also. Okay.
हम्म।
Okay. Okay, guys. Thank
Thank
you
you,
for
sir.
your time.
ये सर कुछ वो है सर, मुझे डेंटल का कुछ इश्यू है तो वो ठीक है, मतलब कि सुबह तो नहीं रखेंगे।
What time you have to go tomorrow or day after tomorrow? Sorry, your voice is not clear. What you were saying something.
Sir, tomorrow I have to go for the dental procedure. Sir,
What time?
around sir, it may be between 10 to 12.
Okay, we'll keep in the evening. Or if I will not be able to take 4 to 5, then I will take this time only. Okay. I hope Vignesh, you no problem with you for the timing.
Yes, sir. No problem.
Okay. Okay, guys. Then thank you for your time. See you tomorrow.
Thank you, sir.